Everybody, welcome back. Today we're doing 2.6, applying the trigonometric ratios. So the lesson focus is going to be using a primary trig ratio to solve a problem modeled by a right triangle. So now we have three primary trig ratios. We did the tangent first, and then we looked at the sine and the cosine. So you'll notice on your screen here, it says solving a triangle means to determine the measures of all angles and all lengths in a triangle. So we know we have, in a right triangle, we have three angles, and we have three sides to go with those angles, okay, that corresponds to those. So when you're asked to solve, you want to have all six. So you might be given three, you got to find the other three, right, and so on. So just a reminder, remember, sine is equal to opposite of hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. The way to remember that is this is something that I remember doing when I was in school. It says SOHCAHTOA, SOHCAHTOA, and that's sine, opposite, hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, adjacent. Okay, so just something to help you reminded. I don't know if we need to remember that, but it's good to get quick, so you don't have to keep going back to your formula sheet. So they are on your formula sheet, like I mentioned, but it's nice just to do a quick memory. That's how I used to recall it. Okay, so to solve a right triangle means to find all the unknown sides and all the unknown angles. Okay, this can be done if you know either at least two sides or one angle other than the side and one side. So these are just some different combinations that you need in order to solve these. Let's look at the first example. Example 1 says solve a right triangle given its two sides. So in this particular example, we were given two sides, and we're asked to solve for triangle x, y, z. So that means we need to find all the remaining angles. So there's two here. We know this one's obviously angle y is 90, so we need to find angle x, angle z, and we have to know the side y also, because we know side z is equal to 6 centimeters and side x is equal to 10 centimeters. So when you start this question, there's a couple ways you can approach it. When I look at this question, like, there's different methods to finding different sides and different angles. So because we have two sides in a right angle triangle, I think of Pythagorean theorem right away. That's just me. Okay, so we can do that right now to determine the sides. So that's the approach I'm going to use at this point right now to get the hypotenuse here. Okay, so that's what we're going to do first. So I'm going to insert an equation, and we know the Pythagorean theorem is the hypotenuse. The hypotenuse squared equal to side squared plus side squared. Okay? So that's all you need to do there. Okay? So the hypotenuse is what we're looking for. I'm going to call that y. Oh, sorry. Make this red. I usually make my answers in red here. Okay? I'll recopy that. So my hypotenuse is the side opposite. That's what we're actually looking for here. So we call that lower y. You may remember in a previous video, remember the angles are uppercase and the sides are lowercase. You can call it xz if you want. It's completely up to yourself. I like to make it simple. So I'm going to call this lowercase y. This side here would be lower z, right? That would be 6. And lower x right there. So the Pythagorean theorem in this case, based on the triangle we have, is y squared is equal to z squared plus x squared. Remember, these are the lowercase. Remember, small z or lower z is the side 6, and lowercase x is 10. So y is what we're looking for. So this is actually, you can put 6.0 in, or you can just put 6. I'm okay with just the 6. There's 10. All right, 10. Next thing we're going to do is we're going to square those numbers. So when we square 6, we get 36. When we square 10, we get 100. Okay? Then you're going to add them together. When we add them together, we get 136. And then you're going to take the square root of both sides. So now what we'll do is we'll take the square root of both sides. So we get y equals square root of 136, and you punch it on your calculator. Get 11.6 619, so on. Just grab a few decimal places from on your calculator, and then the last you'll say y is equal to 11 decimal, and it says the nearest tenth, so the 6 rounds the 6 up to a 7. Don't forget your units, centimeters, and that's it. That's going to give you the side x to z, or lower y, whatever you want to call it. So the length of xz, if you wish, or you can just say y is approximately 11.7 centimeters. Okay? That gives you the sides. So now you have all the sides. Now what you want to do is you want to find the unknown angles. Okay? So the first one we'll find, we know y is 90 degrees, obviously. So that's given. You don't have to find that. So now we're going to look for angle x and angle z. Okay? I recommend using the given sides. You can use the 11.7 if you wish, but I'm just going to use the given sides here. So the first one I'm going to find is, I'm going to find angle angle x. Angle x, remember it's capital, is equal to question mark, right? So this is what we're looking for. So if we look for angle x, we know the side opposite and we know the side adjacent. So we have opposite over the adjacent side, and we know that ratio is the tan. Okay? So to solve for that, we put the opposite side in to x. Opposite of x is 10. Leave your units out. They're going to divide anyway, centimeter divided by centimeter. And the adjacent side is 6. So we plug that in. Sorry about that. Back, so you know where you saw where it came from. All right. So then once you plug it in, then what you're going to do is you're going to do the inverse operation. So you'll say that angle x is equal to the inverse tan. So that's tan to the -1. That's the second function on your calculator, or most calculators anyway. All right. And then you're going to do you don't got to find the decimal there. There's no need to divide that. Just plug it in your calculator as you see it, like that. Okay. And then we get angle x equal to, we calculate that plug it in our calculator. And you're going to get a decimal, obviously. So we're going to plug that in now. So when you plug that in your calculator, you get 59.03624, and so on. And then what we're going to do is we'll put our final answer is 59 decimal. And it said all the measures are nearest 10, so one place after the decimal, so I was just going to leave it at 0. As I mentioned in class, I have to keep the 0 there if it says the 10th, even if we know it's 0. But we still have to write that in, okay? It's very important, we don't forget that. And there you are. So angle x is 59 degrees, approximately 59 degrees. And you can do another tan ratio if you want, using z as 6/10. Or an easier calculation, in my opinion, when you're looking for angle Z would be, it's simply equal to, remember the two angles in a 90-degree angle other than a 90, in a right triangle, equal 90. So to get the angle Z, it's just going to be 90 degrees. Okay, it's going to be 90 degrees minus the 59 degrees. So it's just 90 degrees minus 59 degrees. All right. And that's going to equal 31 degrees. Okay? And that's it. Again, there's a number of ways you can do this. You don't need to use tan. You could have used sine or cos with the given angle. There's a number of ways to approach this question. You didn't have to use Pythagorean theorem. You could have found the side, but in my opinion, what I've done here today in this example is the easiest, or the most efficient, maybe I should say, not necessarily the easiest, but the most efficient way to find all the measures. So I found the unknown side and the two unknown angles. So now I have all 6 measures, because angle Y, we know, you can write it down, but we know it's 90 degrees, right? Okay, so that's it. I'll stop here, and we'll do example 2 and 3 in the next video. Thank you very much for watching, and I hope these videos are helping you along the way. If you have any questions, please let me know in class. Thanks.